The deal is there are features on the ocean floor, like besides just the ocean floor sloping down or sloping up, there are also seamounts. Seamounts, hey, thanks, grab one of those. Seamounts are mountains on the ocean floor, like mountains that come up. And then there are also depressions in the ocean floor, like holes in the ocean floor. There's like seats over there if you want. That cool. Um, and those depressions or holes in the ocean floor are seen. Both depressions and the seamounts are, you know, they're circles on that. Like instead of it being just like a straight line, there's circles, and the circles can kind of stack up. All right, so this chart here, these are all depths. They're all in feet. They could be in meters or whatever. It sort of doesn't make a whole lot of difference. But so you want to get about 10 lines on the map. So you got to figure out what the contour interval's got to be. I don't know, what's the greatest depth on this one? It's like 127 maybe. There's like 127 down at the bottom. I mean, it doesn't have to be perfect. And then what's the shallowest? Let's see. 74, I guess. Yeah, 74. All right, so generally you want to take the greatest depth and the shallowest depth. And if you subtract the shallowest depth from the greatest depth, 127 minus 74, that gives you 53. And 53 divided by 10 is like 5.3. But you don't go every 5.3, you go like every 5. So, and then, you know, it doesn't matter where you start, but you're going to go by every 5 and like multiples of 5. So, I don't know, I'd start like with the 100 maybe. You don't have to start at the edge of the map. You can start anywhere you want. And, you know, so it'll be like 100, 105, 110, 115, and then going down like 95, 90, 85 and whatnot. So I'll put the 100 in. And then what I want you to do is 100 is like that. That one's pretty simple. And then the 105. So there's a thing that you're going to notice. Up here, one thing you can do is kind of pre-plan how these numbers have to be. So there's like 95 and 122. You're going to have to fit the 100, 105, 110, 115, and 120 all in like this space. You know, there's going to be a lot of lines. They're all going to be like pretty close. Actually, let me back this up a little bit. So maybe like that. But then there are other places where, you know, like the 110 is going to be here, but the 120 is way down there. So between two lines might be really far apart. But up here there's going to be a lot of them all packed in like real tight. That's like the 100, 110. Or, oh yeah, we got to do the 105 as well. 110, 105. And one important principle is that these lines never cross each other. They never cross each other, but they might get really close, like the 105. And the 115 is going to be really close in here too. But then down toward the bottom right corner of the map, those get really like, really spaced out. There's this thing up there. Yep. All right, so keep trying to put the lines on there every 5. So you always got values above 5 on one side and below 5 on the other, or values above the number on one side and below the number on the other side. Yeah. Gotta have one number bigger on one side, smaller on the other. In the end, they all might look a little bit different, but you know, it's close. Yep. Yeah, there's 125s down here.
And then there's one on the left, right next to it.
Yeah, there's like one little one here. So that could be like a little,
Yeah, oh,
like it can include the 125. You know what I'm saying? There's nothing bigger than 125 over there. So like 120. Let me see. Erase.
does that say 116?
Yeah, like 116. Yeah. Yeah, that copy's not so great.
Yeah. Well, because that means there's like a little. Wait, where do you see this? There's a little 105 on the right.
Wait, this one here?
Where's that 112?
112? Yeah, like 112. Like, oh no, my mouse isn't on there. Wait a second. That's this mouse. I don't know why that froze. Oh, the zoom is like really behind.
There's no 160.
There's no what?
There's no 160.
No, not 160. Like, it won't go to one. He was saying 116.
Oh,
Yeah.
Oh,
No, he was thinking like this said like this one over here. There's a like it looked like 116, but yeah, it's 112. So, okay, now things get a little bit confusing and complicated down here, you know, because you got some different sorts of numbers. Um, so one thing I see is there's other places where there are small numbers kind of like in a group. So you see how there's like a 95 and a 97, kind of like down in here and the 100. So the 95 and the 97 are kind of isolated all by themselves. And there is a 100. So here's what I want you to see. If I draw a circle like this, if the rule is, I don't know why it's taking so long. Like our Wi-Fi has been really slow this morning. There it goes. Wait, it's on that one, but it's not on this one yet. Well, that's kind of annoying. All right, so see, I drew this circle, and the rule is that everything on one side of the circle is less than the number, and everything on the other side is greater than. So for the circle, see, everything outside it is bigger than 100, everything inside is less than 100, you know? And the 100 is right on the line itself. So when you see like little numbers that are kind of isolated on their own, they're finally caught up on this side. Then there's like a circle there. Now the 105, it's the same deal. Okay, so 105 also has to exist like in here, kind of like that. And again, everything inside the circle is less than 105, and everything outside of the circle is greater than 105. This is like a little depression, like a little hole, or not a depression. This is a seamount. It comes up a little bit higher because these numbers are the depth. So the depth of the water is 95 feet here, but then it gets deeper all around it. So this is actually like a seamount that comes up. This point is higher up than the surrounding water, or the surrounding ocean floor. And then the 110 has got to be 110. It's like this. And then there'd have to be a 115. And then a 120. I stopped writing a while ago. There finally finishes. Okay, so these individual lines are the 100, 105, 110, 115, and 120. I think we can, there's a 125 as well. 125 is going to be, there's a 125 down here. Like this. And you could also do a little one like that. So this is a 125. This is also 125. I think that's about complete. All right. So a couple different ways to visualize like what is going on in this diagram is you have this ocean floor that's about 120, 125 feet deep. And it's this area that's like in here. And then on that section of the ocean floor, there's a feature where there's a seamount. So the ocean floor is like flat, but then there's this like mountain that comes up on the ocean floor. And that's this mountain here. Because the bigger the number, the greater the depth of water. And not only that, but from the ocean floor here, it then rises up to be more and more shallow. So this is the shallowest place on the map. It's 74 feet, and the seafloor drops off, and it's flat down here, and there's a seamount. So circles can be seamounts that are like mountains that come up. The circles can also be depressions on the ocean floor, like a trough or something like that. Whenever you go, if you're trying to get from like the ocean floor up to this higher point, going from here to here, it's very steep. It rises up very steep from like here to here because the lines are very close. But then over here, if you were to go north, like you go long distances before you cross lines, so it's a lot more gradual of a slope. So it's difficult to, I mean, if you can draw it in 3 dimensions with shading, that would be cool, but that's the plan. So when you just look at the numbers at first, you can't tell that there's a seamount or there's a depression or how the ocean floor rises up, but that's very common. This 125 is okay to do, just like a little thing, because if it goes through the 125 and everything to this side is less than 125, there are no numbers that are bigger than 125. Down here, it's a little more obvious because we can have a number that's less than 125 below it, numbers smaller than 125 above it, and the thing runs through the 125 going between like 126 and 116, 126 and 122. It's sort of not necessary to have like a circle for 95. You know, you might be like, well, if this is 100, why not have one for 95 and just be a closed circle? That's not always done. Well, Oh, there's another 120 down here too. Let's see, this can actually go. This can go like that. I missed those. Let's see, 120, that's good. It's sometimes difficult to label these numbers in here, but one way that those can be labeled besides putting them at the edge of the map is to like not have the line and then write a number where the line would be. So this is the 120 depth. And then this is like a 115, so you could erase that, but you end up with a whole lot of those numbers and it gets kind of annoying to write and can be really globbed up. So it's understood that if the interval is every 5 feet and you see these smaller numbers, then you can see that these must be like the 100, the 100, 105, 110, 115, 120. But you wouldn't have to label all of them necessarily, just so there's some kind of reference or whatever. I think that's all right. You know, and up here, you know, it's totally okay if your line goes through the 85, but you want to try to make them as smooth as you can. You might not have it exactly like this. You know, they could be a little more spaced out here. Typically, what's not typical is that there's a big gap in the smaller gaps. So sometimes what people do is revise it by like maybe moving this one down a little bit, moving this one up a little bit, so they're kind of a little more evenly spaced, because that's typically how land goes. It usually is like really steep and then kind of a shallow slope. So this little feature here, we call that a seamount. So whenever a mountain is on land, you just call a mountain. When a mountain's under the ocean, call it a seamount. It's so weird that that's like many seconds behind. All right, questions or thoughts about that? Yep.
So anything above the line 120 has to be smaller. It has to be below 120.
You're talking about this 120 or that?
The line.
This one here?
Yes.
Yeah. So everything on this side is less than 120. Everything on this side is greater than 120.
But I was trying to do my 125. I kind of just like, I did like follow that rule.
Yeah. Now, a thing that might be a little confusing is you're like, well, there's a line here for 120, but then there's another line for 120. And that's totally normal because this is like the deepest place that's greater than 120. And then you go like shallower here and shallower there. So another clue that this is a place called a saddle. So a saddle is like, you know, if you have a hill and it goes down like that, we call it a valley or a saddle or a pass. Underwater, it's called a saddle usually, kind of like, you know, like a, well, the front to back of a saddle, like on a horse. So this is higher up and then down and then up. So if you were to go from like here to here, it's like going like this, like that. So 120 in a way is like a depth that's like that, 120 feet. So there's a place here that's 120 and a place there that's 120. Does that make sense? It's a new and good way to visualize like how the ocean floor shape is. And in some of the other maps we looked at, they'll be like, you know, then shaded. And how the shading works is, you know, you just like pick different colors for the different regions. You might be like, oh, we'll make this like red and it's like a reddish orange and then like orange and orangish yellow and then yellow. And you just keep changing the color. And those colors here would then repeat on this side so that this 100 line, whatever colors in here, would be the same as the color in there. It gives you an indication that they happen to be at the same elevation. That's another way to quickly see them. Other questions? Okay. The second one, it has a big 2 at the top. Let's see. Yeah, it's in the upper right hand corner. It's got like oh yeah, so here for instance, this is the one I just drew, but this is one that I drew earlier. So if you watch up on the screen, I'll click the other one. When I click it, it like looks a little bit different, but it looks like the same. So if I just like go back and forth, see how like it's kind of the same, but it's kind of different. That's okay because like every time you do it, it just kind of comes up just slightly different. That's totally normal. All right, so follow the same procedure. Figure out what the contour interval's got to be. You know, subtract the smallest step from the greatest step, divide by 10, round it to something that's by 5, by 10, by 20, by 30, by 50, by 100, whatever. And then try to draw the lines in on it. Let's see, 52, 7. It looks like the greatest step's 52, the smallest step's 7. Subtract those, you get 45. Oop, you don't divide by 2, you divide by 10. I don't know why I wrote 2 there. Oh, crap. Let's see. 52 minus 7. 10. 52 minus 7 is 45. 45 out of 10 is 4.5. Just go over 5. You know, I kind of look at the middle of the map and then pick something that's like a round mount. Like I might start with a 30. You know what I mean? Sometimes starting at the edge can be tough because you get those like little like circle things, but I don't know. Over here, there's also the 10, so that's kind of nice. You just be like, bang out the 10, then like, bang out the 15. So it doesn't make a difference what you start with as long as you're going by fives. And sometimes you might, things go nice and even on one part of the map, and then you're like, oh, this is a hot mess. So then you go to a different place on the map, and as you add the lines up, you start eliminating places. Yeah, it is. In that previous one, like when you start at the top and work your way down, it's easy for a while, and then you get that mess with all those numbers, and that's when you start seeing the circles. But the circles can't overlap the straight lines, so it leaves you less area to have to deal with. You know what I mean? You kind of never know where to start. You just got to start. What's that? Oh yeah. Another thing that people find helpful is, although you're going by fives, you could start out by going by tens and then fill in the ones in between. Like do 10, 20, 30, 40, and then go back and do the 15, 25, and 35. Sometimes that's helpful too. You can't do it wrong. As long as a line is a multiple of 5, you just kind of throw it on the map. When you get a line that looks like it has a dead end, just stop worrying about that line and move on to a different one. So for instance, here I've drew the 10 to 15 and 20. But when I go to do the 25, you'll see I'm like, okay, here's a 25, and it goes down like this, and that's all kind of nice. And then I get down in here, and I'm like, well, now where do I go? Because like now these numbers are greater than 25, so just stop. You haven't done anything wrong yet. You just got to like hold off on that. Then maybe try the 30. So now when you try the 30, that ends up to like work out pretty nice. So there's something going on in here where there's the 25, but then there's also like numbers bigger than 30. You got you're gonna have to have lines for 30 and lines for 35 kind of in here. There's also a 24, which is even like less than 20, which is less than 25. The lines can't actually stop somewhere in the map. They have to go all the way to the edge or be continuous or be a loop. But we'll have to figure that one out. So then 35 is like this. There's no numbers that are impossible. So here's like a little hint. Kind of here in the middle right part of this map, there's kind of sort of not really random numbers, but it's hard to tell where this 25 goes. But a thing that I see is I see numbers that are greater than 30 and numbers that are less than 30. So somewhere in here, there's got to be a line for 30, and it has to be like a whole circle, kind of like this. So I put numbers that are greater than 30 inside it and numbers that are less than 30 on the outside. So this little line here has got to be a 30. There's also numbers that are greater than 35 and a number including 35. But you see, there's no other numbers that are like 25 that are down in here. So what that means is this line has got to go back up. It's got to like get back up to the top somewhere. You can also see that, um, so if 20's got to be, if 20 to 25 is on one side of the line and 25 is on the other side of the line, it's going to kind of have to double back. Well, there's a 25 all by itself. That's kind of annoying. Let me move this over. And it's tricky because you got 25s and you got 26s that are all really close to each other. let's see, 20, 25. You know, this is actually simpler. Let's see, 25. Yeah, there's not a closed loop. That's it. 25 like this. There's like a stray 25 up here, but that's okay. Okay, now in the last one, that loop was a seamount. This loop is not a seamount. It's a hole. It's a depression. Because all this area between the 25 and 30, this is all between 25 and 30 feet deep. But then you've got areas that are greater than 30 feet, greater than 35 feet. So the shore might be over here on the right, and it gradually slopes down toward the bottom left to get deeper. The shallowest is up here, and the deepest is down toward the lower left. But here, as you're going deeper and deeper and deeper, it gets deeper and then it comes back up. So this circle isn't a seamount that comes up, it's a depression, it's a hole. That's totally normal, it's totally natural. Those exist all over the place. Seamounts are actually more common than single trenches, but sometimes there are undersea cave systems. It could have been a coral reef that collapsed. Depending upon the way the currents move and waves move, there could be sediment removal from a place. What's that? Yeah, it's like that. Yep, so it's a seamount. Yep. So like on topographic maps, the bigger the number, like the higher the land, because it's the height above sea level. For bathymetric charts, the number is the depth of the water. So the bigger the number, the deeper the water is. The smaller the number, the shallower the water is. So you can think about it in two ways. It's the position of the, it's both the depth of the water, because we care about the ocean, the water itself, but it's also the distance to where the land is below the water surface. And actually, this is always marked as MSL, which stands for mean sea level, because the ocean has tides. The tides come up and down. So the issue is you could be somewhere that has like a tide that's up or down by 5 feet from the median. So if it says 20, that's mean sea level or average. At high tide, this could be 25. At low tide could be 15, because the tides can go up and down by many feet. Like you may if you've ever been to a beach, you might like build a sand castle, and the sand castle's 10 feet from the water. And then as the tide comes in, it takes your sand castle away. Or it's also really there's lots of YouTube videos. It's kind of funny, but also kind of sad. People like park their car like right at the edge of the beach, and go for like a walk, and the tide comes in and swallows the car. Yeah, because what happens as the water washes up against the tires, it erodes the sand, and your car will get buried. Not bury the whole car, but it'll get buried right to the door sills. And you're not getting out because now it's sloppy, wet mud, and your car is right on the door sills. If the tide's big enough and there's high enough waves, it could wash your car out to sea. Car doors seal pretty well. Cars actually float in water fairly decently. It's one reason why you should never drive through water, because with the doors closed, the bottom of the vehicle and the doors sealed up, it's buoyant. You usually for most cars, if you get about in water, so it's about 3 inches above the door sill, the car will then float. The tires are full of air, they float. Yeah. Never, ever, ever, ever drive in standing or moving water unless you got a Jeep. Because the whole point of Jeeping is like to get stuck and lost and roll it over. Yeah. Well, there are high water vehicles that are designed for high water use. Like some military vehicles are intentionally designed to ford water. Like, to be certified to go to some depth. Some cars have or vehicles have snorkels that come in. With freshwater, it's one thing. Generally, with salt water, you never ever want to do it. Salt water is so corrosive. Yeah, because like a lot like you can get like snorkel kits for trucks for the air intake and exhaust, and that's all good. You can go through freshwater, but you submerge into salt water and come back out, and the salt water starts intruding on electrical parts and stuff. You might finish the day, but then you wake up the next morning and be like, "How come my car won't start?" And you ruined it.
Or if you drive an American car, it's like, where did my car go? Because all the rest of the
It's weight reduction.
Because like every time I see somebody in Pennsylvania with the salt life sticker, like the salt life sticker, I'm like, they don't really understand salt life.
Yeah.
Salt life.
489. I live that salt life with my aquariums. It's a different salt life though. This one you want to go about every 10. Um, this is the third one, number 3. I don't know. I'll do it at the 400, I guess. Whatever. 390. If you do stuff like that, you can bet your insurance company will not be happy. Like you'll pay your full deductible, and then your rate's going to go way up. If you like flood your car or it gets washed out to sea, they like if you hit a deer, you pay your deductible, and your premium doesn't go up because it's like it's an accident. Or like sometimes people, you can drive cars out on the ice to go ice fishing if the ice is thick enough, but you're taking at your own risk. You go out and the ice is too shallow and your car falls through. Like depending upon the waterway you put it in, you have to get the vehicle removed. So if they can get it out in the wintertime, it's one thing. If you got to wait till the spring and hire a barge to go out and lift your vehicle out of the water, like that operation could cost tens of thousands of dollars in addition to the loss of the vehicle. So this one's pretty chill till you get down toward the bottom. And then there's a line for 470. Just kind of like this. And then a line for 480. And then 450. And 440. I think that's about it. So, yep, down here there's a C mount, 440, 450, 440, 450, 460. I missed it. Let's see, 470. That's wrong. Less than 460. Oh, less than 460 is like this. Yeah, something like that. So this line for 440, 450, 460, 470. There could be a 480 in there too. So there's a C mount here that comes up. This is like the highest point, and then it slopes down on all sides. This is like the greatest depth, like the abyssal plane of the bottom, and then it slopes back up. This is the shallowest place is up here at 380. You could have a little line for 380 if you want, but it drops off by every 10 feet for every line. It's a nice flat place, little dealio like that. These are actually places on the ocean floor. These are from like the NOAA thing, and you can download little sections of the bathymetric chart features. It takes too long to make these up because you got to like draw the lines to type all the numbers. These are actually places on the ocean floor. All right, deuces.
Hey, Tesla's down a little bit today.
Good.
It's
Get her
like
down to.
720.
Oh, that was where it was yesterday.
No, I got up. I think I got up more than yesterday.
Down 395 on the day. So what's up for today?
Is it really?
Yeah. Pizza Hut took a slam. That's okay. I got out of Pizza Hut. Or not Pizza Hut, Papa John's.
Oh, really?
I've actually invested in Papa John's a lot. You know, I was talking about trading on bad news because Papa John's owner,
yeah.
he's friggin' insane.
I know.
Like he'll straight up, it'll be like his stock will be doing like I'll sell his stock, and then all of a sudden he'll like go to a board meeting and like drop the N word, and then like the stock drops by 30%, and then you're like, yes, I'm gonna buy, and then he got fired by the company, and as soon as he got fired by the company, the stock went through the roof again, and then he was talking smack about, like, you know, he always had those promos for football, and then when people were like disappointed that the Washington Redskins weren't going to be called the Redskins anymore, even though it had nothing to do with the company, he like tweeted about it and the stock dropped like 30% because there's these people who invest, they don't even know he doesn't work for the company anymore. Like they're just dumb. They're like, hey, Reddit.
Yeah, wait, that's Papa John.
Yeah,
That's
that is
Papa
Papa John. John Shatner.
Yeah. See you.
See you.